in on those. They could come from any sheet, anywhere in the book or whatever, but I would focus my energy on those kinds of problems, right? So, who found something that we have a question about that we need to talk about? Emily.
Letter E, for number 8 on review sheet 1.
Review sheet 1, number 8E. Review sheet 1, number 8E. Okay, this is a word problem and it does not give me a formula. So, what do I need to do before I do anything? I need to do what? Figure out which formula I'm going to use. So that's what I'm going to do. I'm going to figure out which formula I'm going to use. So what are kind of some of the things that help me determine which formula I'm going to use?
If it says monthly.
Does it talk about payments? All right, that narrows it down for me. If it talks about payments, then I know I'm going to use one of the ones from the book, right? Or, aren't they on the sheet? Put my sheet somewhere. Yep, they're right there on the sheet, down at the bottom of the sheet. All right, so I know I'm going to be using one of those. Or how do I decide which one of those I'm going to use? How do I know? What's the difference between those two formulas? One is if I'm saving for the future, and the other is if I am paying off an existing debt. So what's happening in this problem? I'm paying something off. So therefore I'm going to use which formula? PV. So I'm going to use the PV formula because I am paying something off. Okay. Why am I missing so many people?
There's retreat.
Are they all in student council?
Hannah Vanderbush, I think.
She went on junior overnight, I know that.
And there's a field trip.
Annie, Clara, Cohen, Bamrick, Brenton. Oh, that's right, he was going to take a college day. All right, well, anyhow, we're going to go without him. So here we go. PV, I'll write the formula down, which is just given to me here. All right, so I'm back to problem E now. The current credit card, okay, so tell me what to put where. Remember, this is the one that sets me off. If you don't know what to go where, I'm not doing it. So somebody has to help me. What goes where?
The percentage goes to I.
Be careful. No, we always want to do that. I is related to the interest rate, but what? Rachel?
Over 6 years.
No, over 12 months. You have to divide the interest rate by the number of times you're paying it. So it would be 0.1899 divided by 12, both places. All right, I have two things missing. What's the exponent here going to be?
72.
Negative 72. And it's 72 because over the course of this loan, how many payments are you going to make? 6 years, 12 a year, 72 payments. What's the present value of the loan? Tells you. Yeah, 1, 2, 3, 4, 5 is the present value of the loan. Am I going to need logarithms to solve this equation? No, I am not. In fact, won't the answer be 1, 2, 3, 4, 5 divided by this?
Yeah.
So I just have to type that in. I'm going to type that numerator in exactly like I wrote it. So I'm typing exactly what I wrote in that numerator, button for button for button for button. And what do I get for my numerator? Somebody tell me.
0.67.
0.67. Now I need to divide that by the denominator, and as always, when there's more than one thing in the denominator, you need parentheses. So I'm going to divide by parentheses, 1899 divided by 12. And now I have the value of this bracket, which those of you typing in with me, what is that?
42.
About 42. So now I'm going to take my 1, 2, 3, 4, 5 and divide it by second answer. So I can see my payment is about $288.51. So I'm going to pay $288.51. That will be the amount of each payment.
I got 291. What did I do with
I don't know. I mean, I'll have to look at it. Did you divide by second answer? Or did you round off the 42 thing?
What's second? Like second answer is 42 point whatever.
Yeah, but you don't round it off. You actually type second answer.
Okay.
Did you round it off?
Yeah.
Okay, she got a wrong answer because she rounded off. And that's going to cost you points. That's going to cost you points. I'm telling you right now. Calculate this number, and then 1, 2, 3, 4, 5 divided by second answer, and that will pull that down without rounding it off. Now, what's this? How do I get this answer to the second part of that question? What will be the total of the payments? Just take that number right there, 288.51 times 72. And you're going to end up paying about $20,772.72. Rachel?
What does the R stand for in the equation?
Honey, open your book. Read the book. Watch the video. Same thing it's always stood for. In both formulas, it stands for the same thing. And I just solved for it. What is it?
The rate.
No, R doesn't have anything to do with the rate. What's the 288.51? Yeah. So what is it? Spurgeon, what is it?
How much you're paying?
Yeah, it's your monthly payment.
I pressed second answer and I still got 2.
Okay, well, I don't know. It's calculator issue. We'll look at it during lunch.
Okay.
We don't want to take up our review time to do that. All right, what's another question we have? All of you are supposed to come with your questions today. What's another one? Otherwise, we jump right into our trigonometry.
Wait, what packet are you on?
It doesn't matter. Wherever you have a question, we'll go to it. I am looking, I am holding the review packet because it makes sense that's where we would be looking right now, but we can go to any of the packets.
Can we do chapter 3 review sheet, problem 3A?
3A on chapter 3 review sheet. So that's the review sheet that we just were on. Well, now we're doing problem 3A, which is a logarithmic equation. And we need to solve it. So I look at this equation, and what's the first thing that I notice about it? I need to combine them, right, Jack? There's too many logarithms over here. I cannot do a problem that has all those logarithms. So I'm going to squish that together. And when I squish it together and make it one logarithm, I'm putting it together, making it one logarithm, how will it go together? As a multiplication. 5 times x minus 2. Remember, when logarithms are added, the numbers are multiplied. So when I squish these two together, it's always going to go together as a times or divide, and in this case it's a times because that's a plus. Okay, now what? Somebody said it. 4 to the second equals 5x minus 10. To get rid of that logarithm, I'm going to translate my equation into its exponent form. So 4 to the second equals 5x minus 10. So 16 equals 5x minus 10, and it looks like x equals 26 fifths. Right? All right, who else had a question about something on any of the sheets? Jack? What? Yeah, but that's, you do that on Monday night. Those things on the back are to get us ready for chapter 4. So we memorize those after we take the test over chapter 3. So Monday you take your test, right? So Monday night you'll work on those. That has nothing to do with chapter 3. That is the chapter 4 stuff. So yes, you need to memorize that stuff, but that's for chapter 4. Otherwise, you won't know what I'm talking about in chapter 4. Cassie?
Can we do 4 A through B, or not A through C, like the ones with the groups?
Hey, what 4 are you talking about?
On the same sheet.
Same review sheet, problem 4. Okay. Problem 4 says simplify all of these exponents. All these things with exponents. So the first one, oh my gosh, I've heard time reading. It looks like 4 to the 3 halves. That's easy. It should take you about 3 seconds if you know how to interpret your fractional exponents. What does a fractional exponent mean? Square root. It means a root, and the denominator tells you which root, and the numerator tells you which power. So my brain, or my eyes, see 4 to the 3 halves, but my brain immediately thinks the square root of 4 cubed. So the square root of 4 is 2, cubed is 8. So that one's done. Same thing here. I immediately translate it. So it's going to be translated into what? The cube root of negative 27 squared. What's the cube root of negative 27? Negative 3. Squared, 9. 10 to the 2/3. Not much I can do with this one. That's the cube root of 10 squared. So I can make that the cube root of 100, but I certainly can't evaluate it without a calculator. And since this is a no calculator problem, that's how I'll have to leave it. The cube root of 10 squared, or the cube root of 100. And then this one is just simplifying exponents. So I've got x to the 5th over x. So what happens there? We can cancel. We're going to be left with x to the 4th on the top. Now we got a negative, and what do we do with him? He comes down, but there's already 4 down there. So I'm going to have a total of y to the 7th on the bottom. David?
On the same sheet, can we do number 2?
Same sheet, number 2. We've been given some values, made up values. And using these made up values, we are supposed to find the log base x of 100. We were not given the log base x of 100. So we need to rewrite 100 in terms of what we were given, right? So Chuck's sitting up here saying that can be 5 times 5 times 2 times 2. So that would be one way of writing it. Now some of you may think of 5 squared times 2 squared, and that's okay. Somehow you got to get this 100 broken down into the given. Now, see how these are all multiplied? Take it apart. Separate them so that you can plug these numbers in. What's this going to be when you separate it? The log base x of 5 plus the log base x of 5 plus the log base x of 2 plus the log base x of 2. Now, do I know this number? Yeah, they gave me that one, so I'm done. All I need to do now is plug in what they gave me, take my calculator out, add it all up, and that's the answer. Easy, easy, easy. Let's do C. There's three. I don't think you need to do all three. Let's do C. It's got a radical in it. All right, what do we do with a radical? Every time we run into one in logarithm land, we write it as its corresponding exponent. So that would be 2x to the 1/4. Now, when you take the logarithm of something to a power, Burkhart's going like this, right? So we bring it to the front, so it's going to be 1/4 log base x of 2x. Now, did they give me 2x? Nope, so I got to break it down more. So I see these are being multiplied. So I can break them down into what? The log base x of 2 plus the log base x of x, which is just 1. Some of you are saying, oh, they didn't give me that. They don't need to. You need to know that is 1. And the log base x of 2 is 0.12. So you're going to add those two together and multiply it by 1/4, and that will be the answer.
0.28.
Okay. I don't know. You got a calculator, yeah, whatever that is. The answers are on the back too. All right. Who else?
On practice test chapter 3, number 5.
Okay, so we're looking at the first practice test, and we're looking at problem number 5. It says evaluate the log base 7 of 19. We're evaluating the log base 7 of 19. Want to know what that equals?
What question is it?
Practice
Number 5.
test 3,
What does it look like?
problem number 5. It's the paper that says practice test chapter 3 at the top, and we are now on problem 5. So what's our strategy here? This is a base 7 logarithm, which is never good. The only time I'm okay with base 7 is if I have something like this, right? That I'm okay with, because that's the log base 7 of 7 squared, which is 2. I can't do that with 19, so what am I going to do? I'm going to rewrite it in its exponent form. Boys and girls, you cannot deal with base 7 logarithms unless you have this special thing going on. If you don't have that special thing going on, you got to get rid of that base 7 logarithm. But now, notice where my variable is. Where is it? An exponent. And when the variable is an exponent, the only way to solve it is to log both sides. So now I'm putting logarithms back in. But the logarithms I'm putting back in are good logarithms because I can type them in on my calculator, right? So x is simply the log of 19 over the log of 7. So I type that in on my calculator and I'll get some 1 point something or other. Okay, Emily? All right, who else had a question on any of the sheets or anything? Want to take about 10 more minutes. Let's use it productively, Jack.
On practice test chapter 3. We did number 2B.
Same sheet that we're on. We're writing the equation of the logistic function. Okay, so what do we need to, how do we need to start? What do we need to do first? We need to know where we're going. What kind of equation am I writing? So it's going to be y equals a over 1 plus bc to the x. Okay, was this problem on the final test review? I'll tell you, yeah, it was. What does that mean? It's on the test. If you can't do that, you're not going to get the right answer because you won't know, I mean, you won't be able to do it. You've got to have this learned. All right, so now they give me all this stuff. I know this is the equation I'm shooting for. They gave me all this information, right? What am I going to do with all this information? I'm going to start figuring stuff out. Where do I start?
Plug in the limit to growth.
Plug in the limit to growth, which is 18. Everybody gets that much right. You should not miss that. You just plug it in. You don't have to do any work. Now what? I plug in my initial value. And when I plug in my initial value, I remember that an initial value of 6 means 0,6. Initial value means the value of y when x is 0, or when t is 0, when this is 0. So I plug that point in. And the good news is, this is 1, so I can kind of ignore that. So then how do I start solving? Multiply and distribute. So 6 plus 6b equals 18. So 6b equals 12 and b equals 2. So when I had this, now I have 18 over 1 plus 2c to the x. Because now I know b is 2. Alright, and then what do? I plug in the other random point they gave me, which is 144/17, is that right? Equals 18 over 1 plus 2c to the 2c to the 2. There we go. Alright, how do I solve that? Cross multiply and distribute. So I'm going to have 144 plus 288c squared equal to, somebody got a calculator with 17 times. What? Thank you. So 288c squared equals, what is that? So 162, double check my arithmetic.
Yeah.
So c squared is 162 over 288, which is 81 over 144, which is 9 over 16.
Is that 3 over 2?
That's right, yeah. That's right.
I'm reducing my fraction. 81. So I got 9/16. So c equals 3/4.
Yeah.
At some point, take the square root. You're going to get 3/4 when you do that. You don't have to reduce it all the way down. So my answer then, after all that, I have everything now. My answer is 18 over 1 plus 2 times 3/4 to the x. It's the limit to growth, so it goes on the top automatically. All right, time for another one. Cassie, was your hand up?
No.
Stretching. I hope your brain is being stretched.
Number 8 on the
Same page, number 8. What is the rate of growth for a strain of bacteria that grows to this in 11 hours? All right, it's a word problem and there is no formula provided, which means you got to come up with it on your own. It's it's a bacteria problem. If it's not a money problem, now I want to clarify something. PERT can be used for money. If the interest is compounded continuously, PERT is your formula. But PERT is the only formula that can be used, the only formula that we have that can be used if it's not money. Okay, so this is going to be used for every non-money problem, but it can also be used for money if the interest is compounded continuously. All right, so what goes where? This is number 8, so what are we putting in where? What goes in for A? 4, 3, 2, 1. What goes in for P? 7, 8, 9. E is Z. What goes in for R? Don't know, but T is 11. Where's my variable? In the exponent. That means logarithms eventually, not yet. Because what's the first thing? Divide. So 4, 3, 2, 1 over 789. Unless that goes in evenly, we are not dividing it. I doubt it goes in evenly. So we're not dividing it, we're just leaving the fraction. Now what? Now we're going to take the natural logarithm of both sides, and anytime you have an ln and an e, they're going to cancel. So we have the logarithm of 4321 over 789 equal to 11r, and our answer is going to be ln, the fraction, divided by 11. So ln, the fraction, divided by 11. So I got this pretty big growth, about what, 15.46%? Okay, time for one more. Rachel.
Number 6 on
Review
review sheet 1.
sheet 1, problem number 6. For 5D, is this equation. Now I'm going to be answering a bunch of questions about this, so I better get a picture of it going here first. What's that going to look like? What's that picture going to look like? Okay, so Chuck knows that the regular logarithmic curve looks like this through the point 1, 0, asymptote at x equals 0. That's what the regular logarithm looks like. That's your BFF that you're supposed to have memorized. Now, this is not quite the normal. We've changed it a little bit. What have we done to it? Left 1. So that picture gets picked up and moved 1 unit to the left. So the asymptote is at -1 and the intercept is at the origin. It's the same picture, just moved 1 unit to the left. So now I have my picture and I can answer some questions about it. What's the domain? You're looking at the red curve. What's the domain? -1 to infinity. Not including -1 because it's an asymptote, but that's your domain. Those are the only x's involved in the problem. What's your range? All real numbers. Or if you're writing it like a mathematician, -infinity to infinity. I don't care how you write it. You can write all real numbers if you want. Is it continuous? Yep. I can draw that entire red curve without lifting my pencil. Is it increasing or decreasing? Increasing on the entire interval. Remember, moving left to right. Every step I take left to right, I'm going up. Does it have any symmetry? Nope. Is it bounded? No. Remember, bounded refers to ceilings and floors. Okay? Not walls, not left and right, but ceilings and floors. Does it have any extrema? No. Extrema, remember, are hills and valleys. We're getting ready to talk about curves that have extrema, your sines and cosines, but not this guy. Asymptotes, yep, already labeled it, x equals -1. End behavior, by its nature, by the kind of curve that it is, it does not have end behavior to negative infinity. It only has end behavior to positive infinity. End behavior, normally, you describe what happens at both ends of the picture. This one does not exist, because can you head toward negative infinity on this picture? There is a wall right here. So this particular curve has no left end. Now what's happening to it though on the right side? As x approaches infinity, as we go farther and farther and farther to the right, what's happening to the curve? It's going to infinity. It's going up. Okay? Alrighty, we're ready for a test on Monday. Now wait, Chuck. We have to figure out when we're going to be back. We are going to be back in our seats at 23. 23, back in our seats, 23. Everybody back in your seats at 23.